Hello friends, in continuation with the last lecture, we will talk about the next topic that is nothing but the vacuum. On the last lecture, what we have seen about the pressure and we defined that physical quantity, and also we talk about the different units used for the measurement of the pressure. Okay, vacuum is also the related to the pressure only, but the concept is quite a little bit different than the pressure one. Okay, so when the pressure comes in our mind, then obviously we talk about the higher pressures only. But let's talk about the what is this different scenario than the pressure or the high pressures. So vacuum has actually the very frequently we debate on this topic, and actually it is a philosophical debate since long time. Since we can have the Greek times, we are debating on this, but was not studied empirically since the until reached the 17th century. Now, in 1643, Ivan Jalista Torricelli produced a first laboratory vacuum, but we haven't defined the vacuum yet. Okay, and we'll see it what is meant by the vacuum in a moment later. Okay, so the it is also Torricelli is one of the unit used for the measurement of the pressure. So torr. Okay, so this is the person who has produced the first time the laboratory vacuum. The experimental techniques developed as a result of his theories of the atmospheric pressure, means the pressure which we feel at the sea level is nothing but the atmospheric pressure. Now, let's define the term vacuum. Actually, it is defined as the volume of the space that is essentially empty of the matter. Means nothing means the actually the vacuum, or as the volume of the space. It is essentially empty of the matter. Means there doesn't exist any kind of the matter. We could have seen in the movies as well. In the space, there is nothing, so that the general astronomers floats in the that space. Okay, so it's a gaseous pressure which is less than the atmospheric pressure. So we can also define that the vacuum is the pressure below the atmospheric pressure is also called as the vacuum. Now, this word has come from the Latin term called as empty. Okay, so the vacuum is the empty. In real practices or in our day-to-day life experiences or the practices, no volume of the space can ever be perfectly empty of the matter. Means it is not possible to remove the all of the gases or the matter out of the some specified space. Okay, that is the limitations of the experimental techniques. In classical notions, or as the in physical systems, what we can with the gaseous pressure of the exactly zero is the only philosophy, or this is what we can say the ideal term or the bookkeeping concept had never observed in the practice. Okay, so we cannot remove the all the gases within the some specified region. It doesn't matter that the how small that area or volume of the space could be. Okay, so and this is what we can say the daydream to get the that vacuum space as empty with the with a matter. Okay, so the quality of the vacuum refers to how closely it approaches to a perfect vacuum. Means how low we can go with the pressures, or we can refer this quality of the vacuum can be referred to how closely we can go to the lowest possible pressure, or the zero pressure. Okay. The residual gas pressure in the space of interest is primarily indicator of the quality and is most commonly measured in the units of the torr. Okay, so the persons who have developed the first vacuum, his name has been given to the one of the unit, that is a torr. Vacuum gauge, actually the for the measurement of the vacuum, we need to have the gauges, and it is used to measure the pressure in the vacuum, which is further divided into the two categories: low vacuum and the high vacuum. Okay, pressure gauges is the device which will be used for the measurement of the pressure which is below the atmospheric pressures. Okay, generally, so we call them as vacuum gauges. And obviously we can have the two categories, not necessarily that we should have the only that pressure which is less than the atmospheric pressure. We can have the higher as well. Okay, so there are two categories, low pressures as well as low vacuum and the high vacuums as well. Okay, so by combining the several gauges, it is possible to measure the system continuously from the 10 millibar down to the 10 raised to minus 11 millibar. Now here what we have defined is nothing but the high vacuum and the low vacuum. So high vacuum means the low pressure and the low vacuum means the high pressure. Do remember this. Okay. Now the many techniques have been developed for the measurement of the pressure, and the instruments used are called as the pressure gauges or the vacuum gauges. Okay, well known as the vacuum gauges or the pressure gauges or gauges generally. The different term apart from this vacuum or the pressure, absolute pressure or PF, it is pressure compared with the zero pressure of the empty scale. Zero pressure of the empty scale means the absolute pressure. This scale has absolute zero pressure as the lowest point, so it is defined as the lowest point which could be observed. So, or else the bookkeeping or the classical notions. A pressure gauge used to measure the unknown pressure in absolute unit balances the uh, unknown pressure against the zero pressure or complete vacuum, and it is expressed in a PSI, that is pounds per square inch. Okay. This is what the unit is used for. So here actually what it compares, there is a one reference level, and with that reference level you just try to compare the pressure present in the space, and it gives us the pressure difference between the 2 points. One is reference one, the other one is actual pressure of the system. So pressure gauge or the P reference, okay, it is the pressure compared with the atmospheric pressure as the lowest point. Okay, so the pressure compared with the atmospheric pressure is as the lowest point. So that is the reference point we keep. The atmospheric pressure uh, is of the 1 bar or the 760 mm of Hg or the 14.7 psi. So these are the different notions used for the notations used for the measurement of the atmospheric pressure. So it can be 1 bar or else equivalent to the 760 mm of Hg or else the 14.7 psi. Gauge pressure by conversion is always positive. Okay, sorry, gauge pressure by convention is always positive. A negative gauge pressure is defined as a vacuum. Negative gauge pressure is defined as the vacuum, means the pressure below the atmospheric pressure is called as a negative pressure. Okay, not like that. Okay, we are having the some negative quantitatively we can have the negative sign to it. No, the unknown pressure in the gauge units can be converted into absolute units by using the relation. And how we can just define it? That is nothing but the absolute pressure is equal to gauge pressure plus atmospheric pressure. So we can get the absolute pressure over there. Now differential pressure is a quite important one, because in the most of the cases it is used, because in differential pressure one of the pressure edge will be end will be the at the reference level, and other will be the at the actual measuring space pressure. So that will give us the difference between this, gives us the differential pressure. So it is simply the measurement of one unknown pressure with respect to another unknown pressure. Okay, one unknown pressure with the another unknown pressure gives us the differential pressure. So it is the difference between the 2 points. Such a type of the measurement is commonly used to measure the pressure drop in a fluid system. Okay, so commonly used to measure the pressure drop in the fluid system. Since the differential pressure is a measure of one pressure reference to the another one, and it is not necessary to specify a pressure reference. Atmospheric pressure is the pressure exerted by the air surrounding the earth at the sea level. Okay, atmospheric pressure, it is the pressure exerted by the air surrounding the earth. It varies with the altitude. Obviously we can refer to this, as we know that our soldiers used to have the high altitude, and their pressure is quite low, so they have very difficulty in the breathing as well. So varies with the altitude, since the air near the earth is compressed by the air above. So as the height increases, as we move towards the mountains, then obviously the air pressure becomes a higher one, and we can have the difficulty in the breathing. So atmospheric pressure is typically about the 100 kilopascal at the sea level. Okay, atmospheric pressure typically 100 kilopascal at the sea level. Now there are the different scale bars used for the measurement of the vacuum or the pressures, right? So this is the atmospheric pressure where we generally live at the sea level, and the gauge readings above this is the gauge scales, and the pressure below the atmospheric pressure are used to have the vacuum scales. So vacuum reading here, and the absolute reading, that is a absolute zero pressure, which is referenced over here. Thank you.